Hi everyone. In this video what we're going to learn is how to tell the difference between a cis and a trans geometric isomer when there's more than just two groups bound to the rigid plane. And so again, what I just want to remind you of is that when on the same side of the rigid plane we refer to these groups as cis. When the groups are on different sides we refer to them as trans. And so a more complex alkene, in this case, is something that has a fluorine, a methyl ether, and a hydrogen on it, where it's not immediately clear which two groups are we comparing for cis and trans. So what we're going to do is we're going to go through an algorithm that's going to help you step by step to figure out whether your molecule of interest is cis or trans. So specifically, the first step, what you want to do is you want to identify the carbons that are being composed of the alkene or the rigid plane. And what I like to do, honestly, is just to make some little dots where those carbons are, just to remind myself where they, what carbons really we're most interested in. Okay, in the second step, on each carbon, examine the groups bound, and rank in terms of increasing priority. So the way in which we rank in terms of increasing priority is related to something called the Kahn-Ingold-Prelog scale, which is essentially just a bunch of people who literally actually got together in a bar and decided, when talking about stereochemistry, what makes something rank higher than the other. And it turns out this is actually not that bad. The way in which you do this is the substituents with higher priority have a higher atomic number. So higher atomic number equals higher priority. So how does this play out on our molecule of interest? So specifically, when we look at our alkene, we're going to examine each carbon individually and ask ourselves which group has a higher priority. So let's look at this carbon first. So this carbon here is bound to a methyl group and a fluoro group. Because carbon has a smaller atomic number than fluorine, we're going to say that fluorine has the higher priority. Cool. We then come over to this carbon. This carbon is bound to a hydrogen and an oxygen of a methyl ether. Because oxygen has a higher atomic number than hydrogen, we're going to say that oxygen has a higher priority. In step 3, we draw a line across our two carbons to illustrate the rigid plane. Okay, so we'll go ahead and do that. I like to just use a dashed line so that we know we're not making bonds. Okay, if your two groups of highest priority are on the same side of this dashed line, then we're cis. If your two groups are on opposite side of this dashed line, then they are trans. And so in this case, because our oxygen of our methyl ether and our fluorine of our fluoro substituent are on opposite sides of our alkene here, of the rigid plane, we're going to say that this is a trans isomer. Using these 3 steps, what we'll be able to do is we'll be able to tell the difference between cis and trans geometric isomers no matter the different substituents that are on our alkene. And in the next video, we're going to practice this with a little bit more complex of groups coming off of our alkene. Okay, stay tuned.